All right, let's get going. A lot of things to do and not enough time to do them, but I'll make time. All right, first of all, if you go to Blackboard, and let me get that set up. All right, everybody should see Blackboard. Thumbs up, people. Good, thank you. All right, this Thursday will be test 3. In July, things get fast, real fast. And every Thursday through the rest of this month, I'll be giving you either a test or a final. And this Thursday will be test number 3 at 8:30. I'll send out the email with the password. You'll have until Friday morning to get it uploaded to Blackboard as a single PDF. Remember, I take off 5 points if you don't do it as a single PDF. My instructions I have on Blackboard give a couple different ways to do that. Test 9 has 9 pages and 20 problems. Some of the problems have multiple parts. There are 5 multiple choice. It will cover gases and solutions, and those are chapters 11, 12, and part of 13. The points breakdown for test number 3, 48 points gases, and 57 solution, which means it adds up to a total 105. Yes, there's 5 bonus points. If you go to the lecture folder in Blackboard, you'll see the important information, which I will give you on test number 3, along with a periodic table and the instructions is already there, so you can see what you don't have to memorize. I recommend on Wednesday, when I'll make it available, you download test number 3, the periodic table PDF if you didn't save it from before, and the instructions that I've had before. All right, as always, Thursday I'll check my email frequently, so if you have any questions, email me. We'll have a regular Zoom meeting again by next Sunday or earlier. I did it earlier this week. I'll post an announcement that your scores are in Blackboard, because I'll have them in by Sunday or earlier. And I'll also, as I did this time, email you, each student separately, your points that you receive for each problem or part of a problem on the test. And next Monday, I'll also go over test number 3 in our Zoom meeting. And like today's meeting, I will delete the test key material from the video. If you need to see anything and you weren't able to make it today, please come to my office hours. All right, again, you should have gotten an email with this, and you should have, can see this anytime you want until next week sometime or later this week. The information, I think it's still Saturday, this will be up, the information on test number 3. All right, let's go to the assignments. And you'll see new Chem 1211 extra credit project. Let's take a look at it. And the extra credit project, which is due by July 16th, no late projects accepted. This is a firm deadline. The project is, and it's extra credit, if you notice, is 10 points. 10 points. And how do you get those 10 points? Well, let's find out. The extra credit project is to create a list of ionic and covalent molecules found in ingredient lists of products that you purchase, can be purchased. In other words, i.e. means that is, things that you can use in your daily life. You must find 5 different molecules that contain only ionic bonds and 5 different, or actually I take it back, 5 different molecules that contain ionic bonds, can't have covalent, and 5 different molecules that contain only covalent bonds. You can use 3 molecules from any one product, which means you got to look at 4 products. That's my way of making you look around. To get the points, you must hand in other words, upload to the assignment area, a table which the product's name, the molecule's name, and whether or not it's ionic. A lot of students forget to do this. Be sure to put your name on the table. To get 1 point, you get 1 point for each correct entry, total of 10 possible points. Now, to make it interesting, you can't use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, also known as ethyl alcohol, sugar, or sodium chloride. Everything else in the universe you can use. Now, let's look at an example. Say you pick up a can of Coke and you look at the ingredients. First thing is water. Remember, water is on do not use list for you, but I can use it as an example. And it's covalent. And if you pick up a can of Campbell's chicken noodle soup or any other variety, you'll see on the label ingredients sodium chloride. And that's ionic. You can't use sodium chloride. That's on the do not use list, but this is what your product table, your table would look like. Product, molecule, bond type. If you can't use Word, you can always handwrite it and scan it or take a picture and upload it. Now, important, ingredients must appear on an ingredients list of the product. Therefore, you can't say air has oxygen, because I've never seen air. I'm walking around my home, outside, or at COD with the ingredients label. You can't say, well, a banana has this. Well, I've never seen an ingredients list label on a banana. Now, this is an optional project. You don't have to submit it. But if you do and get it right, you can get up to 10 points. Now, a couple of hints. One, you can use Google to look at the structure, or before it's due, email me your list and I'll tell you what's right or wrong and give you time to change it. And that way, when you upload it to the assignment area, you'll do it and get your 10 correctly and get your 10 points. Now, important thing, to listen carefully. If you see an alkali metal in the name of a molecule, it's got an ionic bond. If you see an alkaline earth metal in the name of a compound, it's got an ionic bond. And if you see the name of a metal, like silver, gold, or whatever, like nickel, it's also got ionic bond. I'll say that again. Alkali metals in the name, like sodium's benzoate, that's got an ionic bond that will be called ionic for the table. It also has covalent, but it's not only covalent. If it says calcium, like calcium citrate, that's got an ionic bond, therefore it's ionic. If you see titanium dioxide, that's got an ionic bond. So anything with a metal or an alkali metal or alkaline earth metal, those are metals, will always have an ionic bond. Now, to show you how simple it is, can everybody see this okay? Carmex, stuff you put on your lips in the winter. I use it a lot. And if you look, there's ingredients label. Will it focus? Well, if you looked at the ingredients label, one of the compounds is phenol. And if you took organic chemistry, you'd learn more about phenol. Phenol is covalent. So, and you can use this one. Shh, don't tell the instructor I'm telling you. But anyways, you put down Carmex, phenol, covalent. There's 1 point. There are at least 2 others you can get from here if you have Carmex to get your 3 points. So I got my 3 points. Now I got to look at something else. Now, where can you find these something else's? Well, if we didn't have wear a mask and be careful outside because of the virus, I'd say go to any big box store and walk down the personal care aisle and pick up things. Well, I don't want you going out because it's dangerous out there. Therefore, go into your bathroom and pick up a number of things you have in your bathroom that have labels on it. You'll find your stuff. If you're still hung up, go down to your kitchen or into your kitchen if you live in an apartment. I live in a home. I used to live in an apartment years and years ago. And open your refrigerator and pick up the ketchup, mustard, pickles, anything else with a label. Or go to where you keep things like cans of soup or other things. Look at those labels. And within about 5 minutes or less, you should have your 10 molecules from 3 different, actually only four different products, because you can only get 3 molecules from a product like this. And if you have any questions, come to my office hour. Also, like I said, it's due a week from this Thursday. That's a hard deadline. If you don't get it in by then, you've just lost 10 points. If you have any questions, see me afterward today or come to my office hour tonight or Wednesday night. All right, any questions on that? So we've done test 3, the extra credit. I'll look at my list. All right, couple things. I've changed the order of things big time because I think it will work better, and I'll explain what I'm doing. I had promised I'd go through today the gas problem set. Nope, I'm going to do that tomorrow. Tomorrow I'll also do my review. Wednesday I'll go through the solutions problem set. Thursday I'll send out the password. We'll still have a Zoom meeting. All right, couple other things. I'm going to switch, and later today I'll change my syllabus, the order of the labs. Instead of doing the Zoom lab tomorrow that's listed in the syllabus, we'll do the solutions one, which I'll do. Hopefully by now you know I do a better job than Zoom. I hope. I think so. And then we'll do the equilibrium lab later on, which is also as Zoom, but I'll write my own for that too. It's going to be a busy week for Dr. White. I got 2 labs I got to create and write for you people. You're worth it. And the other thing is, since I wisely, I hope, spent extra time for test number 2, and I'll be going through the key and right after I'm done now, I have to spend a little extra time this week. So Tuesday and maybe Thursday, I will be spending, instead of 1 hour, an hour and a half. Trust me, I'd rather be done in an hour because I can then be done. But you people are worth it. And if you can't stick around, it'll be on the Zoom video, so you can always come back and catch it. All right, any questions so far? Going once, twice. All right, let's talk about test number 2. You should have gotten your test back, score in Blackboard. Also, speaking about scores, I'm up to date, and there's a holiday surprise I did for the last Zoom lab. Go look at the Blackboard scores, but I'm pretty much up to date on that. And test number 2, what can I say? Test number 2. I'm so happy you guys did fantastic. It's summer, you're fighting the virus, you're fighting the fact that COD made me cut down the amount of lectures I could give, and you guys are doing great. Hold on. Real great. The class average, if I remember correctly, was 90. Normally on a test 2, I expect the class average for a good class to be 85. I've had classes, the class average on test 2 has been 70. And you guys nailed it with a 90. Most of you did real good. A few of you have some problems. If you have problems, come to my office hour or email me and I'll set up a special time. But all of you did really good. There are a few things where I'll go over, and right now I'm going to go over the whole test. I'm going to go over a little quicker because you guys did good. By the way, test 2 is the hardest. 3 and 4 are not easy, but this one's the killer, and you didn't get killed by it. I shouldn't use that terminology considering what's happening. Couple of things. Everybody stop, hold on. All right. One of the nice things I do, which is different, usually I hand the papers back if we were in a classroom and you could check when I went through. Check each problem from the email, each part of the problem from the email that I sent you. If I made a mistake, then email me and I'll correct it, because no student should ever will be penalized in my class for a mistake I made. That's not the way I teach. That's not the way I grade. So if I made a mistake you think I did, email me, because I got your tests, you uploaded them, I still have them, and I shall do that. All right, if I took off points for 4.91, let's hold on, well, I'll check. Maybe I just copied it wrong for my calculation, because I think most of you got it right. I don't remember, either you got it wrong or you got it right. Quick, Yuan, did you check your email? With the,
yes, you didn't mark it wrong, but I mean.
I think I just copied it wrong.
Yeah.
4.91.
Okay.
I make a mistake. Bad, Dr. White. All right, let's go through something important. One of the questions I would have if I were in your shoes is, what grade am I getting right now in this class? Well, good news, most of you are still doing real good. Well, you did real good on the test. There are two ways based on, you always drop the lowest test. And if you didn't do good on this test, you still have a chance of doing good in the class, but there are two ways. Look at your two test scores. Look at the higher one. If it's 90 and above, you're getting an A, 80 to 89, B, 70 to 79, C, and below that, 70s, 69, D, below 60, F. Now, the other way of doing it is take your first and second test scores, add them up, divided by the number 2. If that number is 90 to 100, you're getting an A, 80 to 89, B, and so on. Now, you might ask, how come you're not doing the lab? Well, if you've been handy in your labs, and just about all of you have, and the lab scores are not that low, they're pretty good, which is the way I grade and also teach so people do well, is labs usually keep your grade the same or raise it. Keep your grade the same. Well, if you're getting an A, you can't get any higher. If you're below an A, doing all the labs, which I think just about all of you have, you'll boost up your score a little. And I've been doing this for a number of years, telling students at this point, just as long as you're handing the labs, don't worry about it now. Also, don't forget, you can do the bonus point project, and that's like adding 10 points to any test if you do it all right. So, any questions? How are we doing on time? Good. Hold on, I just got to set up something. Nope, I haven't disappeared. I'm just some stuff I didn't have open that I thought I did. I have to open. And now we're ready for business. All right, let's get back to solutions. And we were talking about molarity. And molarity is moles of solute per 1 liter of solution. And that's not what I want. Hold on, I just had way too much open on my PC. I'm closing stuff right now. All right, thumbs up, people. Do you see molarity on this? Thank you. All right. So molarity, capital M, is moles of solute per liter of solution. Because 1 liter equals 1,000 milliliters, molarity for us is really moles of solute per 1,000 milliliters. Now, there are a couple important questions. I'm going to do some of them right now. Thumbs up, people. Can you see the problem? Thank you. All right, let's look at this problem. And the question is, how many moles of sulfuric acid, that's H2SO4, it's called sulfuric acid, that's the most widely manufactured chemical in the United States. More pounds of H2SO4 are produced yearly than any other chemical in the United States, if not the world. And so what are we trying to find? Moles of H2SO4. What are we given? How many milliliters? We're also given this strange number. As soon as you see capital M, what does that mean? Molarity. And molarity here would be 7.612 moles of sulfuric acid per 1,000 milliliters. And therefore, it's time to use your good buddy, your good friend, unit analysis. Whatever I have to start with, I'm going to start with, and that's 751 milliliters. I have some conversion ratio. What units am I trying to get to? Moles of H2SO4. That's an M, looks like garbage, so I better fix it up. Still learning how to write on the tablet. That's better. I have to take my time. And I noticed some of you did this on the test, so you must like my red arrows. Whatever I'm trying to get rid of goes underneath. Whatever I'm trying to get to, the units go on top. Here is moles of sulfuric acid. Here it's milliliters. Where do I get that number? From knowing that the molarity means this, and therefore it's 7.612 per 1,000 milliliters. Now, this is three significant figures. This is four significant figures, and this is an exact number. Exact number doesn't play a role. When you multiply and divide, you get the same number of significant figures as the number that has the fewest. So this would be three significant figures. And therefore, let me write this down, because now I go to my calculator. Before I do that, notice milliliters cancel out. Anything divided by itself equals number 1. And now I can go to my calculator. Thumbs up, people. Can you see the spreadsheet? Thank you. And round this off to three significant figures. Keep the 5, keep the 7, keep the 1, use the 6 to round off. That's 5 or higher. Therefore, I drop all this, increase the 1 to 2, and my answer would be 5.72 moles. And if I look at the clock, it's time for a break. Take a 5-minute break, come back in 5 minutes. Dr. White gets through his stretching exercises, and I see a question. Do you see me now? Shahana, can you see me? All right, I'm back. All right, take a break. I'll be back in 5 minutes at 9:55. All right, let's get started. Ring, ring, getting all back to the classroom. Do you ever see the old movies? The school marm had a bell to get the students back from recess. When I was in first, second, third grade, they had a speaker and you heard a buzzer go off or something. I don't remember. That was a long time ago. But anyways, let's do another one of those type of problems. Why don't you try this one yourself? How many milliliters of HCl must you use to get 3.61 moles? I could have put down HCl. Moles of HCl of a 3.33 capital M HCl solution. Hint, use your good buddy, your good friend, unit analysis. Why don't you try this one? And when you're done, don't forget to look up and smile. And once again, let me tell everybody how proud I am of all of you for doing well on test 2. I think you guys got the hang of my good buddy, my good friend, unit analysis. And it does help. You don't have to do the math, just set it up. But if you want to do the math, I'm not going to stop you. And when you're done, if you can give a thumbs up, I appreciate it. Give you about 25 seconds more because most of you are done. Those who are done early, please be patient. I try and give everybody time to do a problem. And I do this in the classroom if we're in a classroom at COD, telling you to be patient. All right, let's do this. What are we being asked to find? How many milliliters of HCl? And what are we given? Well, we are given this, how many moles we want to get, and we're also given this number. As soon as you see capital M, you know that's molarity, and molarity is 3.33, whatever your number, moles, in this case, HCl, per 1,000 milliliters. You can do a liter, but I always give my problems in milliliters, so you'd have to convert. This way it's easier. So the only thing we have to start with is this. And now, what do we want to get to? Milliliters of HCl. So it's time to use your good buddy, your good friend, unit analysis. And whatever you're trying to get rid of goes underneath the ratio. Whatever you're trying to get to goes on top. So here we have milliliters. Here we have moles of HCl. And where do we get those numbers? Right here. For every 1,000 milliliters, there's 3.33 moles of HCl. And before I pick up my calculator, notice moles divided by moles cancel out, because anything divided by itself is number one. I'm left with the correct units, and therefore I can now pick up my calculator. All right, what doesn't it like? Let's try this again. All right. And notice my number is in milliliters and three significant figures. This one, if I were to put it in scientific notation, might be easier for you. I can do it this way. If we look here, keep the 1, keep the 0. All right, I was just checking to see if everybody could read it. I see some people round it off either way correctly, but let me do it. Keep the 1, keep the 0, keep the 8. This is 4 or less, so this would be dropped. It would be 1.08 times 10 to the third, or 1,080. And let me go back to my whiteboard. And the answer could be either 1.08 times 10 to the third, or either way, because Dr. White knows his numbers. Get off my screen, 1 sec. And either one would be the correct way. Now, it turns out molarity is a very useful concept. As you just saw, if I needed so many moles for a reaction, and I had a certain molar solution already made up in a tank or a drum or in a bottle, I could just measure out volume a certain amount. Like the one we just did, you'd measure out 10,000 or 1,080 milliliters, or if you wanted to be exact and go more significant figures, 1084. But anyways, those are called stock solutions. And it's a very important part of chemistry. If we're in COD, the next lab, I'd go into the lab storeroom and bring out a bottle or two of various stock solutions. And stock solutions are so important that, if I can find it, all right. Thumbs up, people. Can you see the internet now with the glass? All right, good. These are called volumetric flasks, and they usually are in multiples of 5 or 10, like 1 mil, 5 mils, 10, 2,500, 200, 250, 500. I think I might have seen a 750, 1,000, 2,000 is the largest I've seen. If you notice here, they have little tiny ones that are oh so cute and bigger ones like this one. If you look at a volumetric flask, see the line right there? When this is 100 mil, you put your solute in there and put some liquid, dissolve it if it's not already dissolved. Then you put enough of solvent, mostly water, to reach that line. And these are accurate to usually 2 or 3 significant figures past the decimal. And this is a special glassware that was created just to make stock solutions. I'm trying to, anyways, I don't have it up with me. I thought I brought it up and I seem to put it somewhere, it disappeared on me. But Dr. White has a collection of those. I have a little 5 milliliter, which this morning when I was looking at it saying, I've got to get myself a 1 milliliter. They're so cute. I've seen 1 or 2. I've never had to use them, but I've used 1 liter as many times as you've opened a refrigerator door in your house. A lot. All right. Now, what does that really mean? In real life, the most important question is how many grams of a solute are needed to make X milliliters of a known molar solution. That's one of the most important things in all of chemistry to know how to do. So let's do that. All right, 10 points. How many grams sodium hydroxide are needed to make 501 milliliters of a 1.23 molar, as capital M is molar, NaOH solution? So what are we being asked to find? Grams of NaOH. What are we given? How much solution? We're also given this number, 1.23 capital M NaOH solution. And whenever you see capital M, that's molarity, moles per 1,000 milliliters. So what that really means is 1.23 moles NaOH per 1,000 milliliters. Now, there's no way I can go from this to this. Can't be done. So you need 2 steps. And the 2 steps are, step 1, you have milliliters and you go to moles. Step 2, moles to grams. So you have to do 2 steps. Let's do the first step. So we have 501 milliliters. And what do we want to get to? We want to get to something to do with NaOH. And this is wrong. My mind is, I'm rushing. And when I rush, I make mistakes. Milliliters to moles. We want to get moles, and that would be a sodium hydroxide. And now we'll use our good buddy, our good friend. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. I want to get moles, NaOH, sodium hydroxide. I want to get milliliters down here. Where do I get these numbers? From here. 1.23 moles of sodium hydroxide per 1,000 milliliters. And notice milliliters cancel out and I'm left with moles. At this point, I'll pick up my calculator. And here's the number I have. Now, there's 2 ways of doing this. You can round off at each step or round off at the very end. I'm a round off at each step person, but I calculated both ways. And so at this point, we have 0.616 moles of sodium hydroxide. Now we do step number 2, which hopefully you learned for test number 2. Ooh, it rhymes. And we'll go from moles to grams. And now, let me give myself a little room. I have 0.616 moles NaOH. I want to go to grams NaOH because that's what I'm trying to find. You look up here, we're trying to find grams of NaOH. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Everybody see this okay? Hold on one sec. What I forgot to do, and I'll correct it for tomorrow's lecture, is when I set it up, I forgot to turn on the mute all when you enter. My mistake, but I can mute everybody. That's for the extra sound. So now, where do we get over here? We want to put moles NaOH. Where do we get this? An important information. I'll remind you, 1 mole compound equals the molecular weight in grams of the compound. And the molecular weight is the sum of all atomic weights: sodium, oxygen, hydrogen. We have 1 of each. I already know this by heart: 23.0, 16.0, 1.01. Add it up. This is a number I use a lot. It's 40.0. Remember, you have the same number of significant figures past the decimal as the number that has the fewest. That's 1, rounded off. 40.01 mole. This cancels out. I'm left with the right units. This is an exact number. 3 significant figure, 3. My answer should have 3 significant figures. Let's go calculate it. I just had to turn off somebody's mic. That was my mistake. If you notice, you get the same number. Both of these rounded off is 24.6 grams. Here is in scientific notation. Here it's this way. You can write it either way. And that's how you do it. So if I had to make this amount, normally it would have been 500, but I didn't want to give you a dilemma of rounding off to 1 significant figure. So that's why I did that. But normally you use 3 significant when you make it. If I mix 24.6 grams with some water, then bring the volume up to 501, I will have a 1.23 molar sodium hydroxide solution. Now, because of the time limit today, I'm going to be doing another one of these probably tomorrow and Wednesday. So, but I do want to finish the chapter today, so I'm going to move on. Again, normally I don't, but I think it was good for me to take extra time to do this. So we did some molarity. Now, listen carefully. Because of the time constraint, I will not, on test number 3 or the final, do any dilution problems. But dilution is where you have a concentrated solution, you add some solvent, and you make it less concentrated. There's a formula here that you can use, and what you're usually adding, trying to figure out is V add, how much you're trying to add to go from the lower volume V1 to the higher volume. This won't be on the test because I want to cover the following. Now, if you were to go into your kitchen and pick up, if you have in your refrigerator, a container of milk, a bottle or a carton or the plastic jug, most of you probably have the plastic. I don't know, glass isn't that well used nowadays or that much. When I was a kid, that's the only way it came. But if you were to pour yourself a glass of milk, you'd say, oh, look at the solution. Wrong. Milk is not a solution. A solution is where you have something, one material totally dissolved in another. In milk, it's not. How can you tell that? If you take a solution, true solution, and you take a flashlight, and you can see the light go through. By the way, time to find out something about Dr. White. He's a flashlight fanatic. I think I have about 25, 30 different flashlights. That's not counting my RGB lights. So T, you know, is a solution. Now, if you did the same thing with milk, and notice I didn't bring up a glass of milk, so I usually don't keep milk in my house. I get my dairy calcium other ways. But anyways, if you don't believe me, take a flashlight, hold it up to a glass of milk, and you won't see the light come through. Why? Because it's not a true solution, and they're small particles of stuff suspended in, it turns out to be water. What are those small particles? Fat and protein, which is in milk. And that's called the colloidal dispersion, which are very important in our life. Now, a colloidal dispersion, by the way, switches on, full blast. This is dispersion of small particles of one substance in another. It's a mixture, but it's not truly dissolved. They're dispersed. And this I won't ask. There's terms, instead of solute, you have dispersed phase. Instead of solvent, you have dispersing media. Number two, I won't ask. Number one, you should know. Now, you should also know what are examples. Well, milk is one. Another one, which is only developed in the late 50s, which I love, is latex paint. Latex paint allows you to wash your brushes and easy clean up with water, as opposed to the old paints where you have to use various organic solvents, and it's safer. And latex paint, if you have a container of it that's clear, you shine a flashlight, the light won't come through. Why? Because the dispersed phase, the particles that are dispersed but not dissolved, block the light. Now, the final example, which please do not try this at home with a flashlight, putting blood in a container, but blood is also not a solution, it's a colloidal dispersion. And the blood, I don't know if you can see my blood vessels there. You can see them right there. The blood in there is not a solution. It's a colloidal dispersion. What is it carrying? Well, it's water, but in there are carbohydrates, amino acids, and fats and oils. And that's being dispersed through my body to do whatever it's supposed to do. By the way, last time Dr. White had organic biology was freshman year of high school. So am I an expert in it? Nope. But I know that much about it. Tea is a solution. Ooh, next time you're in your kitchen, take out the bottle of ketchup and shine a light through it. You can do the same with mustard. No, those are not solutions. Those are colloidal dispersions. Now, if you have a glass of pop, that's a solution. So you shouldn't be able to identify for test number 3, what's the solution you use in your daily life and what's a colloidal dispersion you use for your daily life. Example solutions, tea. Now, coffee, depending how thick you make it, may or may not be. I can go either way. I'm not a coffee drinker, so I've never taken a flashlight. I don't like coffee. But I love tea.
Okay, Dr. White, can we say about oil?
Oil?
Oil is it's a colloidal or solution?
What kind of oil are you talking about?
Olive oil.
What? So food as opposed to for your car. Because when you say the word oil, there are various things I could think of. Now, if you look at olive oil, as long as it's not frozen, if it's a liquid at room temperature, trust me, I've done it with vegetable oil, you can take a flashlight and light will go through it. And therefore, it's a solution, but actually, well, olive oil even is a mixture of different fats, or not fats, different oils of different, I'm doing organic chemistry. It's a solution. Okay. Now, water itself, if I have pure water, that's not a solution, that's not a colloidal dispersion, it's a pure substance. Now, if I put sugar in here and went like this, and after a couple of, oh, the sugar's gone. If I would take my green flashlight, I'd see it's a solution. And therefore, you have it. Now, if you were to put sand in there, that's no longer a solution because it's not homogeneous. Think of all the stuff you're learning. And that's how you tell it. So let's go through this again, because this is very important. A solution, you can shine a flashlight through it. A colloidal dispersion, because you have small particles floating around, not truly dissolved. Oh, I like that, not truly dissolved. You take a flashlight, red flashlight, it would not go through it, just like it doesn't go through my hand, though my hand is not a colloidal dispersion, it's a solid. But anyways, now Dr. White's getting silly, but I've been doing that the whole semester. If you had something that was colloidal dispersion, the small little particles block the light so it doesn't come through. And now you know everything about colloidal dispersions. Next time you're with friends at dinner, if you're doing a Zoom dinner, hopefully you are, you should tell them, you know, your blood is a colloidal dispersion, not a solution. No, don't do that. You lose friends real quick. Now, I see I have about a minute or so, and I'll come back to the how many grams 10-point problem. Tomorrow, I will be doing my review for test number 3 this Thursday. I'll be switching the labs on lab. We won't do the Labster lab. I'll be changing sometime today my syllabus, but I'll be posting today or early tomorrow morning my lab for Tuesday's lab on solutions. Then I'll post my lab along with the Labster. Oh, by the way, interesting, the last Labster one, I got stuck on something, I got upset. So I know the part where if you ask for help and they come back to you next day. Well, Dr. White did what Dr. White knows how to be a senior manager in a company. And besides saying I got stuck, or I was looking for the ideal gas law lab, which happened to be in physics hidden. I had looked in physics, but I couldn't find it. I also put down, could you please give me the email address of your CEO, who I already tried finding and couldn't. And lo and behold, that person did. So sometime this week, I'll be contacting the CEO of Labster and let them know, 1, the emperor has no clothes, which means their labs suck, excuse my language, but they stink. And 2, I can help. We'll see where it goes. I don't expect them to get back, but at least I'll try. All right. Last minute, I want to talk about something that's totally won't be on any test or final, but it's very important. Over the weekend, one of the things as a PhD chemist, I guess any PhD scientist, you never stop learning. You're trained to teach yourself things. That's part of our training. One of the things I read about this weekend was the fact that COVID-19, people have been talking about how when you sneeze or cough or talk, particles come out with the virus, droplets from your mouth and your nose. That's why you wear a mask. Well, turns out about 250 scientists signed a letter to WHO, the World Health Organization, saying you should also consider aerosols, which I sort of knew what they were. I've never really worked with them, and I learned about it. And turns out I already knew aerosols are very fine particles that stay suspended in the air for a long time, a lot longer than droplets. And this could be a major source of how you get the virus from someone else. Now, Dr. White, if you haven't figured, I'm above 65. I'm not underweight, I'm overweight, and I have high blood pressure, which I control with medication, so I can do things like mow the lawn and yard work I did Saturday morning for about 2 hours and not die. I'm still alive. But serious, I had a mask, and since it was 7:15 when I was out mowing, nobody else was out. But I have coordinated. I have a big lawn front and back. I saw a couple across the street. People were walking. Immediately, the mask that was here went on top of my face when I saw them about a half block down until they went, and for about, because I knew about aerosols. And you should be aware of that. And later on, when I was mowing my backyard, a neighbor came out with his kids. Mask came up immediately. As soon as I saw them walk out their back door, their backyard, I waved to them and kept the mask on. And this is something important so you don't get sick. You saw the pictures over the weekend of younger people going to big parties and beaches with no mask. God help them, because hopefully they won't, but unfortunately might come down with the virus. And if you notice, it's killing people all ages if you're not careful. So be careful. If you go out, wear a mask. I do. I don't do it now because you're not going to get it over the internet. I joke about it, but be serious with that. I'm going to end. If you need help, office hour tonight. And don't forget to use the new login, my mistake. With that, bye.